My name is Roman Kutushenko. Today I'm going to talk about secure firmware updates on the web. It's a quite complex problem because we do not want to see solutions like one symmetric key on each device and sharing of firmware each is encrypted by this key. This is not our way. We are going to use elliptic curve cryptography. In this video, we'll use Virgil security sandbox for IoTKit. This will help us to emulate a whole process of manufacturing of devices and up to secure firmware update. Okay, let's start Virgil's sandbox. For Mac OS and for Windows, you should have installed Vagrant, this virtual box. For Linux, you need only Docker. This sandbox uses communication with real devices, not only the simulate devices, so that's why we need to bypass our network interface. For my case, it's Wi-Fi, first one. During bringing up of Sandbox, we'll need application token from Virgil. It's free token. You are able to create it using Virgil security website. For my case, it's already done. Copying it and inserting. Sandbox continuing to start. It's almost done. Well, it's done. Okay, let's open Google Chrome. Localhost port 8000. Well, we're here. Let's take a look to top right side. It's the first action is generate provision package. Generate provision package, in fact, it's generation of root of trust. For different systems, you will generate different types of root of trust. Possibly you want to use classical model using X509. Certificates, maybe you want to use RSA. That's funny to use RSA nowadays, but anyway, this system is quite different. We do not want to use long chains of certificates. We do not want to use huge sizes of X509. That's why we use a different module here. Let's take a look into it. Well, looks like it's here. It contains of root key, firmware key, auth key, and trust list key, and also trust list. Do not pay much attention here, but all these elements will be generated by clicking that button, and public parts of keys will be used as root of trust. One important thing about firmware update on these slides, it's here. It's here. Your firmware should be signed using two types of keys. It's firmware key and auth key. I think in this case we need two men to sign firmware. First one is from some firmware team, and another one is boss, which signs this new firmware too. All these keys could be generated and uploaded into files. It's not very secure way. This system gives possibility to you to use some HSM modules, hardware security modules. On the left side, we see YubiKey. On the right side, we see Atmel dongle. Actually, it's microchip dongle already. It contains ATEC 508A integrated circuit, or 608A. It's a modern version of this chip. Well, so then you generate your root of trust. You free to choose to use files or security modules. Well, it's a generation of root of trust. Let's get back to our sandbox and let's generate provisioning package. Generating. On the bottom, we see logs. Logs contains each type of key, each type of key pair, and trust list too. Well, so you are owner of some manufacturing process, and you already created root of trust for you. On the next step, you want to produce some devices on your factory, have factory. You should pass to factory some data to manufacture your devices. At first, you need some initial firmware. This firmware should be used for self-test of device. It's a common practice. Also, this firmware should contain elements to upload root of trust. I'm talking about public keys and trust list, which is signed set of public keys too. Also, this firmware have to generate a key pair of this device. Private key per each device is on this device only. It will not leave it anyway. Common usage of generation process, it's inside of HSM module 2. It's very good practice. Then your IoT device has HSM module. Well, so on factory you have initial firmware, you have a root of trust, and you have some utilities that will help you to do with complex process. So, by the way, Virgil IoTKit contains all required utilities that will help you during your manufacturing. Well, let's emulate creation of IoT devices. There are two types of devices. It's a gateway and device. Gateway, it's any device which is connected to internet, and device, it's any device which connected to gateway. Let it be one gateway, and let it be 10 devices. Well, oops. Here is it. We see MAC addresses of devices, and we know that all devices are not initialized, and cloud status is not registered for each device. Let's perform provisioning process. During this provisioning process, each device will get a root of trust. It will generate own key pair, and it will sign CSR for registration in cloud. Well, let's do it. Remember, it's your manufacturing process. It's some manufacturing line on your factory. Well, it's already done. We see that initialized status is yes, and let's register all these devices in cloud. One thing, I've mentioned that private keys are generated inside of each device. Could you remember about Amazon? How do they generate private keys? Think about it. Never mind. Let's go. Let's move forward. So, then the performed registration process. All devices uh, have been moved from factory section to end user home. Actually, after registration of devices, they are ready to be used by end user. So we see here version all zeros. In fact, your initial server could contain any version. So um, we have workable devices which are in homes of your end users. Well, let's think that right now we want to share some new firmware. We fixed some important bugs and we want to share this new firmware. Its action on top right to its signed and published new firmware. Let's click it. Here are two types of devices. Two. First one, gateway. Next one is device. Um, every firmware contains own mark, own version. In fact, it's some C structure that contains information about device. But we have two types here. This difference is in way of delivery of firmware. Gateway always connected to internet. So this is simplest part of firmware update. Let's do it and let's talk about how it works. Well, stop. do not click publish, and let's take a look onto this picture. It's this picture describes delivery process to your gateways. First of all, you have to create your firmware. This firmware is passed to some protected PC that will have your important files, these private keys, or this PC has connected to USB dongles anyway. Here you will get signed firmware update. This update could be compressed or something else, but it's update file. Then update file should be uploaded to administration console. You are able to use web interface, or you could use terminal. Anyway, it's uploading process. After uploading, administration console service informs message bin service. Message bin service, it's something like MQTT plus some additional stuff. Message bin service informs all devices that are connected to internet about new firmware. After that, these devices request own firmware. Each device downloads its own firmware, stores it in some space in flash. It uncompresses it, or etc. It verifies signatures and informs system about new firmware. After that, a logic of your device will make decision about most suitable time to most convenient time to reboot your device and install it. Well, let's see. gateway publish. Publishing is done. Well, and we see a new version. It's not emulation inside of your Docker or VirtualBox. This process includes real publishing to service and real usage of message bean. So it's only emulation of devices, not of all services in cloud. So this was simple way. Then Gateway received new firmware and it made decision to reboot. We have emulated bootloader. Bootloader. Take a look onto requirement to install new firmware. It verifies it too. And if new firmware is okay, then bootloader make some changes in Flash to boot from new firmware. In case if new firmware is broken, it's bad but possible situation. After new reboot, bootloader should move back to stable version. This is very important. Okay. So this was a simple way. Then IT device is connected to internet. But what we will do this all these devices? Let's think that it's only Bluetooth low energy, no internet connection, only Bluetooth low energy. So in this case, let's do it at first, and after that let's talk about it. Publish it, then sign it, publish it, and versions are here. Versions are here. Actually, we have all logs, localhost, but another port. All utilities, all devices, everything is here. Everything is here. Information about, it's stop. Requests, everything is here. Do not pay much attention. Well, let's talk about the way of new firmware to your small devices. Your gateway should know about devices connected to it. And in this case, Gateway downloads not only firmware, but firmware for all types of devices that are connected to it. So after download, Gateway and these devices are they are using some special protocol. It's a snap protocol, but in real life you are able to change it. You can use your own protocol, but we use snap protocol. It's our own protocol. It informs all devices about new firmware. In case if device is running right now. In case if device is turned off, it will ask about new firmware on its boot. So then any small device informed about new firmware. It works this gateway like this file server. It will take its own firmware by chunks. It stores in some part of Flash, and after that it behaves like Gateway. So small device contains bootloader 2, it uses same type of verification and etc. That's all. That's all. This while process of delivery of new firmware to gateways and to small devices. Well, guys, thank you for your attention. Mm, in fact, you are able to try it by yourself. It's a Virgil security IoTKit. As I mentioned, you need only Vagrant or only Docker for Linux. Well, thank you very much and bye bye.